just wanted to show you this quickly. You know, we're just getting into this. As you guys know, this is the section of the gymnasiums right now. We should go over a few things. One thing that's been discussed is the idea of a possible mezzanine in the gymnasium. I'd like to just touch on that. We're working with some bleacher manufacturers right now to see if that happens. Now, what you can see here is this is actually a section of the gymnasium looking back at the front entrance. The front entrance is over here. The grade is out here. Again, stack the bleachers on this side. The court would shift over slightly. What we're looking at the possibility of doing is stacking the bleachers on one side, having a mezzanine level that can be accessed from this side, and then we can have bleachers all on one side to access from the top and from the bottom. That's still in development, but we just wanted you to see how that
Let me
works.
say that that is an example of additional square footage and additional cost, because the balcony that would need to provide access, have to provide access to the bleachers, is additional square footage. And
It's not a tremendous amount, but it's square
it's
footage.
just,
and
it's
it's all-
just another little contribution to the total count. So,
Does it also provide the area where the bleachers slide underneath it, so you have that area no matter what, when your bleachers are retracted?
You do, but you have to count it if you have people walking on it. In terms of BSF, you have to count it. So even if you had, yes, we would anticipate doing that, is to stack the bleachers underneath this balcony so it's hidden away, which is great. But then if you have a balcony that's here, bleachers stacked underneath it, that's where footage is going to be counted on this level as well as on this level. So you do have that.
And why would we do that?
So it's based on the last meeting that we talked about being able to access, like in the original design from the second layer or the second level of the, that was something that this committee wanted them to look at.
it's a great amenity.
Yeah.
It changes the whole gymnasium. for the
It
better.
makes it like it's a,
Yeah.
Well, it was a nice feature in the other buildings. I remember that. People liked it.
so we don't have a tremendous amount to show you about that today, but we're looking into it. We think it looks like it's possible. From a technical standpoint, obviously budget will have to work on it, but we're excited about the possibility of having that happen. So,
Of course you do.
yeah.
Of course we,
More importantly, what we've been looking at with our structural engineer is how we're going to structure this gymnasium. And we had shown you this form before. We had looked at a couple different options. I think the easy answer that everybody would say when you first look at something like this is to just do a truss all the way across and then frame up with light gauge or some light steel members. What we found when we looked into that was that this span is a very large span. It's almost a 90-foot span. So to do a truss that is that long, and you're doing them every 8 feet or so, it's a tremendous amount of truss work, and it's a certain cost. What we had the idea of doing was possibly doing, you're looking at this in longitudinal direction, but a long truss running along this peaked edge, running from one side of the gym to the other, and then doing a shorter span of long span trusses between these two trusses. And then connecting across with some steel members, it gives us an opportunity, a large opportunity to do duct work and mechanicals running through. We looked at this with our structural engineer. At his first glance, he thinks this would be a much more economical way to solve the problem in terms of the amount of steel that you have. We're excited about it because it brings a lot of interesting design opportunities. If we have glass on the skylight along here, you have all the light filtering through a large truss member. I'm trying to think of an example of where you may have seen a truss this size. This would be like a 10 to 12 foot deep truss. Any examples of,
it's about as high as this room.
very large truss member that would run from one side of the gym to the other, and then off of that, these trusses would be hung off of it, and we have a steel member that goes across the tie of the outside wall. And then from the top of that truss member, you can run down, steel framing. So that we're very excited about it, because we think it not only provides some interest, but it's more economical. It also provides this area for mechanicals, which is very hard to do. When you do a long span truss like this, what you're really usually trying to do is run all your duct work and all your piping through that truss. It can be done, you've probably seen it in other places, but it's a coordination difficulty, to say the least. And Joe's probably going into some pretty hectic problems with
Yeah, the
that.
other neat thing about this too is that you see the trusses which are things go across the gymnasium. By doing this, they actually reduce the depth of that by, I think, like 2 feet.
Yeah.
So thereby you can get your building height, but you also have less envelope, and the envelope's pretty expensive as well. So there's kind of a lot of neat pluses.
Yeah. And what Joe's referring to is if you were to span this truss we're showing from here to here, outside wall to outside wall, this bottom cord would drop almost 2 feet. And it's a lot more steel. It seems like the economical way to approach it, but you're doing an incredibly long span, and these trusses would be probably 8, maybe 12 feet on center, so there's a lot. So by shortening the span, we're knocking off almost, maybe 30 feet of it, which is a tremendous amount at that distance.
So we're taking advantage of the volume in the pitched roof form. It's not the way it's usually done, but it really does work.
So the big trusses would be bearing at gable ends only
Yes.
and clear span the rest of it? And they're 90 feet,
Oh, those are about 130.
130, so transportation's not a problem?
You know, we talked about that.
That was one of the first
Still
questions.
splicing?
They'll have to
That was my
splice.
first question, no splicing, yeah.
On site?
Yeah, yeah. They'll bring them up in probably 2 pieces. And then they'll, so it'll be, they'll kind of angle them on the truck.
So, I mean, to say the least, it's very exciting for us. I mean, we think that it just provides a very, it's an economical solution, but it also provides some great opportunities, design opportunities.
Our structural engineer also likes it from a snow loading standpoint.
Well, I was really gonna go next, was we had talked for a while about the possibility of taking this pitch roof form and bringing it up in order to get a vertical face here. We talked about the snow sliding off and finding its way into this corner, and is that a susceptible corner to leak? In doing some of the calculations, the structural engineer was saying that the second you start to put a vertical piece here, you start to add a lot of loading to your roof. You have snow loading that's sliding off the roof. You have then drift load, if you can imagine that this piece came up vertically and did this. You have snow drift load that comes up here, you have sliding load that comes down. So the loading gets pretty heavy at these corners. So we would have to increase our steel members, for one. But more importantly, and Joe said it best, he asked in the past, I like less joints. If you did this and you brought it up vertically, you have 1, 2, 3 joints of susceptibility for leaking. If we were able to do it like this and have a continuous membrane that starts at the peak, goes down and goes all the way up, you have no joint there. And that can provide, and the snow then would just stack up like this. There's no snow drifting. Just as a conceptual look, the snow would stack like that, and there's no joints in the roof. Or there's very less joints in the roof. So from a technical standpoint, again, that is a much more, better roof that will have much less likelihood of leaking. Now, we're working with some roofing consultants right now about the best way to solve this problem. We do want to have metal here and metal here. We're looking at, can this membrane come underneath and we have decorative metal over the top? That's something that we're trying to work on right now. But we just wanted to show you what our thinking was at this point, at a very early stage. And it looks like a lot of things that are in our favor that we think could be very advantageous to the building. The other thing is that by bringing this up, not only do we add loading and all those, it's added cost. I mean, this wall would come up 6 feet along a 130-foot span, so it's a tremendous amount more exterior skin, and that would be all around the whole building. So we're interested in it. We think it's got a lot more development to be done, but this is where we are. Is there any questions about it? It's been a point of contention. We want to make sure we talked about it.
Would you be lowering the building at all with the 2 feet, or are you just giving the room more headroom?
I can't say that we would have determined that yet. I
Okay.
think that's a good question, and if we have the opportunity to do so, we should. Once our engineers get a little bit more input into this gymnasium, we'll be able to know if we have the opportunity to do it.
Well, the height's gonna be driven by athletic codes, so it's gonna be the CIAC. It's usually volleyball, collegiate, I think it's 35 or 36.
Well, volleyball for high school is more like, is a little lower.
Is it like
I think
30?
It's like 23, I think.
23 or
It
24.
was like 23, that's for high school now. It's low, but For collegiate, I know it's up to mid-30s.
But we can, in this, we can really get our mechanicals up high, so there's nothing underneath the cord of the truss.
So,
But you know, obviously they'll get the right volume for us too.
Hmm?
You'll get the right volume
Yes,
for
that's
us.
right.
and so that, you know, that means that this whole roof structure has to come up a foot or down a foot, and we have the ability to make that adjustment. By doing the other things we talked about, we just keep adding to the structural depth, and we start to lose the ability to make some adjustment without the building just skyrocketing up, if you will, so. So anyhow, that's where we are. You know, we're very interested in the truss and the mezzanine. I think it would be just a tremendous amenity to the school, so.
Fire rating construction.
This should be brought up as well. The mezzanine will trigger fire rating of the structure of this steel. So,
What does that mean?
That-
Bad
he just
or
did a
good?
big
What does
sigh.
that mean?
And that's a consideration, because if a lot of that steel is exposed, then you're talking intumescent paint, which is gonna be
Yeah.
a very expensive proposition.
is there something to really, I mean, right now, the way, I'll just say this, the way that our building is set up, we have protected steel, 1 hour protected steel everywhere. You can get away from protected steel if your steel is a minimum, I believe, is 17.5 feet above your floor line. What happens is right now, the steel is 17 feet above floor line. If you put a mezzanine in, that will trigger the,
And it matters not what the floor is made of.
just, it's not compatible level.
That's good, that's gonna have to be a major consideration,
Yeah,
the issue
now-
of mezzanine, because that's gonna be a very significant cost.
And just to give you the ins of that, if we're on the other side of the building and there's a floor right here, if we have a structure that runs up here, and that structure of this, that holds this floor up, also holds the roof up for the gym, that will trigger it as well. So what we intended to do prior to talking about this mezzanine is have 2 separate lines of structure. So this line of structure and this line of structure are completely separate, and that's how you don't have to fire rate the gym structure. So it's a major consideration because it'll be a cost item. So,
Well, we'll have information at next meeting. We can go later, we can go
I'm so
down.
excited about that.
it's not to say it can't be done, but it's something that if I feel like.
How wide's the mezzanine, how wide's the mezzanine, you get
I would-
fireproof above it?
No, it's the whole space.
And it's not the cheap spray on fireproofing, I'm sure that's exposed steel, that's gonna have to be intumescent paint, which is.
Let's evaluate it, because, you know, it depends on what the bottom of the truss is. you know.
I thought the initial estimate that the gymnasium and the auditorium had fireproofing as part of within the budget, and that the classroom wing or the 2 wings that got separated out to not having, I thought.
We had to spray on all the lower levels, as Brooke said, typically you're not required in those high spaces to have the fireproofing because of the distance. So we didn't carry fireproofing in those spaces, we carried some mess, I think, out in the center hub area, some of the exposed steel out in there, but not widespread in an auditorium, because typically those spans are so high that it's not required.
And the auditorium is an example, that would be triggered because of the balcony. But there it's a lot easier because we can cover it, you can do a 1 hour rated ceiling.
So you can do conventional
Simple.
spray.
Or you can do conventional spray and it's hidden because you have clouds and stuff. Gymnasium is a lot more difficult to achieve that. So that mezzanine there is that trick to it, so we have to evaluate
I
that.
think we need to evaluate it architecturally, yeah, and then we come back with the mezzanine, here's the premium and without. Here's the cost to consider. And then that's a choice.
Is that all interior glazing?
Yes, this is actually looking back at the lobby. So yes, the front door is right here, you walk in, this is all that interior glazing.
Now, was any of that, you remember when we were looking over budget and we were gonna eliminate some of that interior glazing, was any of that part of it, or was it someplace else?
Well, we can probably bring it down a little.
No, I don't know, I'm just saying, I know we're doing a percentage.
I was thinking, as I was driving here, I was thinking actually doing every second one is solid. Cutting the price in half.
I think at the point of
Was this one of our
engineering,
trade-offs?
we were targeting numbers, so, you know, I can't say that we've really evaluated that, so really.
I know we had some in the learning common and some other places, but I can't remember that one.
I think that maybe we need to do probably a little bit of a lighting study as well as the sun study, because basketball backcourt would be in front of that, right?
Mhm.
So, and then on the other side is the lobby, and there's a lot of glazing on the other side, so the question is whether that's gonna be an issue with the
Right, just like having an exterior.
So the other end of the truss is bearing on glazing in the wall?
Well, yeah.
What do we call it?
It's stuff.
Ah,
You don't see the
You'll think
structural.
okay.
You love
Just more expensive.
Yeah, right.
Anyhow, you know, that's part of the development we're doing now, that we're excited to show you how all the structure works and such, but we thought that this was a point that you should see how we're thinking about it.
How much seating are you estimating would be on that?
Well, I don't want to give you a total number now, because the bleacher people, when I say the bleacher people, that's not someone in our office, that's like Hussey Corporation, they're doing some drawings for us right now. And they'll determine, you know, what our maximum capacity is. We're also looking at putting bleachers on the end of the gym as well, on the north side of the gym, so that when the door is closed, we have some seating for the smaller gym as well.
And how much were you anticipating in that balcony area for the seating?
Well, I don't think there'd be any seating in the balcony as much as it'd be a walkway, but then you can walk right onto the.
It's a walkway, you weren't gonna sit up there.
But the walkway allows some standing room, but it also allows you to walk on to the.
Enter from the top of the water. Because there's no, if you don't have that, the only access you would have to the gymnasium would be to go downstairs.
But you still have viewing from that common area up on top through all that.
That's right.
And basically that was
That's
what
they
was
like.
in the original building,
Right.
was that people could stand in that common area, if you will, and look down into the gym, so that mezzanine really, you know, it was nice, but, well, I take what Joe's saying. Let's get the cost on it and
Yeah.
evaluate it, and we can do it, but if not, it's not a big thing to cut.